In the previous chapter, we took a look at conductors, materials where electrons are free to move around in macroscopic movements. Today, in this lecture, we'll be talking about dielectrics. So let's first start off with an introduction. If our material is not a conductor, then it most likely is an insulator. So let's first determine what an insulator is. An insulator is a material where electrons are tightly bound to the atom. So material where electrons are tightly bound to the atom with negligible macroscopic movements within an external applied electric field. Okay, so moving on, we have something called dielectric. So a dielectric is an insulating material that can be polarized. So let's first take a look at what this polarization means. If I have an object in its neutral state, then let's say it has positive and negative charge distributed evenly around. But when polarized, a dipole is formed. So you're going to have a negative charge on one side and an induced positive charge on the other side. And that happens when you apply an external electric field. So in this case, your bound electrons are displaced over subatomic or microscopic distances. So this kind of material that is polarized is now called a dielectric. So let's define a dielectric as an insulating material that can be polarized when an external E field is applied. So that gives us a good introduction to insulators and dielectrics. The next step is to take a look at what this polarization means.